Hello dear Phasmatic friends! Today we are studying how to rationalize expressions. Follow me please. First of all, we have to explain that rationalize is to disappear the root from the denominator and to make appear a root in the numerator, or to disappear the root from the numerator and make appear a root into the denominator. How? Finding equivalent expressions. So, here we are explaining how to do that with monomials. In the next videos, I am going to explain how to do it with polynomials. First of all, if we want to disappear this cube root from here, we are going to multiply this fraction by two monomials identical. Because if you multiply something by the same thing divided by the same thing, you are multiplying the expression by 1. And if you multiply one expression by 1, it is the same expression. You are going to get an equivalent expression. So, if you have cube root, you put cube root. If you have square root, you are going to put square root, etc. So, you are going to put something in order to get one exponent that is the same as the number that is here. So, if you have x here, you need x squared, because when you multiply x by x squared, you get x cubed. And x cubed can be simplified with the cube root. After that, you can write a y. You need a y, because y times y squared is y cubed. If here you have a 3, you need, after doing the multiplication, a 3. If here you have a 2, square root, you need to get exponents 2 after doing the multiplication. And if you put here x squared y, in the numerator you are going to write x squared y. And why? If you have not understood, you are going to see we multiply the numerator 3xy times the cube root of x squared y over only one cube root of x times x squared x cubed, y squared times y, y cubed. So I have made it intentionally because here we can simplify the cube root with the cube root with the cube. So we get here 3xy times the cube root of x squared y over xy, and x divided by x, y divided by y, goodbye. Final answer will be 3 times the cube root of x squared y. What happened? Well, I have disappeared the cube root from the denominator and it has passed to the numerator, because in the denominator is like having a 1, a number 1. Next example. If you want to disappear a square root from the numerator, you are going to multiply that by a square root in the numerator and the denominator. So for disappearing a 2 that has a 1 as exponent, you're going to put another number 2. The a to the power of 4 doesn't need to be put, because here you have you could need an even exponent, because it is a square root, and here you have a number that is bigger than this exponent. So if you think a little bit about properties, you can simplify this 4 with this 2, because a to the power of 4 can be written as a squared times a squared. So you don't need to write anything about a. And b, you need to write a b here, because b times b, b squared. That can be simplified with the square root. If you have written 2b here, you write 2b here also. So you multiply that, and you're going to have the square root of 2 times 2, 2 squared. A to the power of 4 can be written as a squared times a squared. And finally, b times b, b squared, over ab times the square root of 2b. Why? Because I can simplify this square root with the 2, this square root with the 2, this square root with the 2, this square root with the 2 exponent. So you get 2aab over ab times the square root of 2b. Finally, a divided by a, goodbye, b divided by b, goodbye. It is valid only if you have all expressions multiplying by themselves. So the final answer is 2a divided by the square root of 2b. And that's it. Because I had a square root in the numerator, but now I have the square root in the denominator, not in the numerator. And here, the same. I had the cube root in the denominator, but now it is in the numerator. Thank you very much, dear Fastmatic friends. See you next time!